My name is Richard Fisher. I am the publisher of Inside GNSS and Inside Unmanned Systems, and we are broadcasting live from the show floor of Xponential 24, San Diego, California. I have today with me, our guest is Jamie Marraccini, Chief Executive Officer of Inertial Labs, and welcome, Jamie.
Thank you.
All right. Glad you have the time to join us today.
My pleasure.
Appreciate your time. So we wanted to talk to Jamie about. There's been a couple of kind of hot button issues and some buzz in this conference this year, particularly, and it relates to the cover of Inside GNSS, talking about GNSS vulnerability, GNSS operations, or UAS operations in GNSS denied environments, and we want to talk to Jamie, who's got a lot of experience in developing solutions that help enable small UAS to operate in GNSS denied. So, Jamie, tell us about Inertial Labs solution, because as I told you before we got on camera, we're starting to hear, Inertial Labs, we're hearing the echo of Inertial Labs out there in the market. Mm-hmm. It seems to be kind of a solution of preference among certain UAS providers, and we just thought we would talk to you and learn more about why that's the case.
I think that, the business itself has been around for 20 years. We've been building up.
So you're a newcomer.
That's right. And so we've been building up these kind of core technologies and the knowledge into the business for a long time.
Yeah.
And inertial navigation, it does start with a good inertial sensor. We're a developer of inertial sensors. We make everything from, kind of like very small, just good enough for doing some navigation with GNSS, to things that are putting pressure on a lot of the fiber optic gyros that are out in the world. So really a lot of know-how in that area. You combine that with maybe some type of magnetometer. We actually design fluxgate magnetometers as well, and then put in a receiver. A lot of partners that we have here where the customer can choose the type of receiver. Each one has its own price performance benefit.
Sure.
And that's kind of your base. And after that, you have to start.
So to be clear, you're GNSS kind of receiver agnostic. You want to interoperate and integrate with all of them.
That's right. Well, with the good ones. I mean,
of course. I mean,
we obviously need to do a little bit of testing, working with the company, sure, and kind of evaluating, which one has the right feature for the right type of project.
Got it. And that feature set is largely driven by the requirements that specified by your customer.
That's right.
And so that's kind of another layer of value that you're bringing to bear to your customer, in terms of, hey, it's not just about the inertial, but we're talking about the full kind of integration, and we can help you with that specification as well.
Is
that correct?
And over the years, what's happened is we've started to expand out from those traditional inputs to a navigation solution, and we've started to add things like computer vision. We've added in some things that protect the receiver, like a SERPA antenna. We're putting in time of flight with radio partner DTC, and adding in other kinds of aiding data, whether it's an alt-nav receiver.
Sure.
And all of these things, they won't fit on every single platform.
Right.
They wouldn't fit from a size, weight, or maybe even a price. But each one brings a different characteristic to the solution.
Right.
And so this is where you engage with the customer, you hear about their kind of use case, and then you're able to make these recommendations. One of the other key things that we've done over the years is, if a customer has a certain method of tracking their own vehicle,
right,
we're able to let them just send the message into the device directly. Everything that we do from a mission computer standpoint is open for the user, the end user, to be able to put their own software on it, to modify the software and things like this. So it can become more of a collaborative integration, even though if they want, they can just buy all the pieces a la carte, sure, and then build the solution.
Sure. So yeah, an overnight success in 20 years, and So you've been hard at it in terms of development and working with your customers and understanding their kind of, the operational requirements that they need to satisfy.
Right.
And being kind of working through those solutions with them has enabled you to have that perspective and go kind of almost in a consultative way, talk about, how do you optimize that, navigation capability with a particular price, with a particular size, weight, feature set, form factor. Can you talk a little bit about that?
Well,
and all the kind of variations that you're seeing. Any trend lines that you're seeing other than, let's reduce size, weight, power, cost, but beyond that in terms of form factor and feature set?
I mean, it's size, weight, power, cost, and from a feature set standpoint, there is no clear feature that someone says this is exactly what I want. Like from a requirement standpoint, there's a lack of there's a lack of kind of organized declaration of what exactly is needed. It's just
Understood.
summarized
And why do you
all
think-
under
why do you-
GNSS vulnerability.
Why do you think that is, Jamie?
Probably because people haven't been able to think of it from a multi-input solution set that has to be geared towards towards the use case. Everyone wants to think of it. It's like saying the word computer vision. Sometimes when you say computer vision, everyone's thinking about computer vision for navigation when it's really navigation with computer vision. You have to think of it as an input and only as an input to your nav system. Otherwise, it can be defeated and it'll kind of leave you short. So
yeah, and I guess where I was going with that question was, it's been our experience that positioning, navigation, timing, and resilient and robust positioning, navigation, and timing is kind of an underappreciated and not well understood aspect to a UAS community. In a lot of cases, you've got military operator, U.S. DoD, and serious players who get it, who have kind of really high requirement, really resilient, robust solutions. But other newer, integrators developing platforms where the PNT kind of requirements aren't really well understood. That's the first problem. The second problem is there are also other data sets that need to be fused with, as you pointed out, that need to be fused that can deliver a more robust solution.
Right.
And they're just simply unaware of the fact that they can fuse those data sets, right?
Well, it really comes down to the people that are building the solution, the vehicle that's going out and doing the job.
Yeah.
They have enough things to worry about with just making that. And
Indeed.
so sometimes the navigation solution is taken for granted because they can get GPS in their test environments and in their in proving out of their system. GPS is available, and with GPS everything becomes easy. Once it is disappeared, then the job becomes very much more difficult.
Yeah.
And it becomes a harder problem to solve. And so the developers of these systems now need to be thinking ahead. The requirement is obviously there. You must operate in a GPS denied environment. And they need to start thinking about where they're going to put these parts and pieces and what parts and pieces. And this is where we come into play to help identify the types of pieces that would complete their navigation solution. And the navigation solution is essential to their overall deliverable that they have, that they're building. And so we like to try and get involved as early as possible with any kind of project to help influence some of the thinking around what to use for solving the GPS denied problem.
Yeah, and understand. And I also think that sometimes the GPS denied problem is not as well understood. Is it intentional interference? Is it unintentional? Is it self-interference? So, having said that, what is your experience in terms of, what kind of trends do you see in terms of user communities? What are the use cases where you think, you're seeing some real kind of progress in terms of delivering a more robust and resilient type of PNT solution? And ultimately, the reason PNT solutions are so kind of foundational to this, to UAS, is because you've got, having that spatial awareness, knowing precisely where this vehicle is, being most always in safety critical applications, and being able to extend the ConOps, being able to extend flight duration, really kind of determines the kind of work that these UAS can do. And to the extent that your company is kind of helping enable longer flight times, more exotic and interesting concept of operations, that kind of puts you at the center of the development side, which is why you like to get involved with companies early.
Right. I mean, so I like you're using the word extend, because this is oftentimes something that you look at when you're modeling out how far could you go just on a pure inertial sensor and reach your goal, like hit your target. And then if you were to step to the next model of our sensor, how much further could you go? Also, if you were to do a little bit of initialization in a certain way, how much does that extend your range? And so each of these things, each little thing you have to do to kind of set the device up and to get it ready for its mission can lead to an extra so many kilometers. As far as like where you see a lot of the activity, extending the range is definitely one, but you're hearing a lot about airborne operations, a lot of fixed wing and multi-rotor. More than probably ever you've heard about little surface vessels, so navigating on water, very difficult to do. And then, getting ignored a little bit are the unmanned ground vehicles.
Sure.
Now, vehicle navigation is something that is easier to solve because you usually have a lot larger of a vehicle, and the price points are generally higher. But as you start shrinking the type of vehicle and also the cost of that vehicle, people aren't going to solve the navigation problem with $100,000 system. They need something that's in the $5,000 system range, and so you have to look at that problem and be able to solve it without a gyro compass, but instead some other methods.
Sure. And there's also challenges there, operationally, in terms of interference, in terms of, you talk about, you get the benefit of the size, weight, power, assuming it's a larger UGV. US DoD is doing plenty of work there, but sometimes you have challenges related to like low dynamic ground vehicles. It can get tricky, right? But so, I mean, essentially, Jamie, what I'm hearing you say is you're an optimizer. You want to kind of optimize that performance for your customer based on their operational requirements, and you also want to make sure that you can do it at a price point and a feature set that will enable them to bring a pretty cool solution to bear in the market. Because ultimately, you want those customers. It's about helping your customers achieve success, right?
Yes.
So can you talk a little bit about that and what you've seen, what you've learned having done that now for 20 years?
I mean, I've always said, these systems now are getting more and more complex, where you have multiple inputs, you have some processing layers, you have an inertial nav system, and at the heart of the inertial navigation system, there is an IMU. And I often say that we engage in all of this complexity in order for us to be able to sell an IMU.
The heart. You heard it here first. The GNSS manufacturers may have another point of view on it, but well said, understood.
So we're really trying to solve the problems because we want to be that IMU provider, but at the same time, as your knowledge of how to go about solving the problem grows, you realize everyone is kind of what I said earlier. They have enough trouble. They have a big enough project just to build that vehicle themselves. Okay, and once they start diving into the navigation solution, oftentimes it's their first taste of building a navigation solution, or maybe they're looking at it from, we have this other tracking device, and we're going to primarily focus on that tracking device. It generally is better if all of these inputs are sort of aligned and calibrated together, and if all of them feed into the navigation filter, rather than doing some separate operations.
Got it.
So
Got it.
that approach is what should help encourage the collaborative approach towards engaging with a company like Inertial Labs, where we bring everything from the sensor to the airspeed sensors and other kinds of inputs into the navigation equation.
Got it. Wow, interesting. Well, Jamie, if our audience want to get some more information, how do they get in touch with Inertial Labs?
Inertiallabs.com.
Okay.
Very easy. info@inertiallabs.com.
Got it. So
we even answer the phone.
They answer the phone. It's radical. Can we text you? No, we won't. That's all the time we have for now. We want to thank our guest, Jamie Marraccini, Chief Executive Officer of Inertial Labs. Jamie, it's been a real pleasure.
Thank you.
Thanks. That's all the time we have for now. We'll see you next time. Thanks.